So let's take a look at this reaction. It's an enthalpy reaction. We're going to say, well, how much heat is given off during the course of this reaction. So a couple of things. This is actually a combustion reaction. So this is actually combustion. And then this is actually propane. So propane's a fuel. You burn it. It's going to react with oxygen to form carbon dioxide gas and water. And it's going to give off energy. And so for this reaction, it gives off 220 kilojoules of energy. That negative sign means it's endothermic. And basically what I can do if it's endothermic, I'm going to write it or write the delta H as a product. So I'm going to say plus 2,220 kilojoules of energy. And so I wrote the stoichiometry. So again, let's just kind of circle this. So again, 1 mole is equal to 5 moles of O2, 3 moles of CO2, 4 moles of water, just like we're always doing. The only thing is, I'm going to say, well, I'm going to write this as part of the stoichiometry too. And so basically, 1 mole of propane will produce 2,220 kilojoules of energy. And so the question is, how much heat is released when 25 grams of propane undergoes combustion? So this is in grams. We got to convert it to moles. So you look up the molar mass, and I think the molar mass is 44.11 grams. That's 1 mole. That's 1 mole of propane, and then 1 mole of propane produces 2,220 kilojoules of energy. So again, it's just a stoichiometry problem. The only difference is we're using energy as one of the products. If you do that, it's going to be 1,260 kilojoules of energy. So in the second part of this, we said how much heat is released when 15.6 grams of water is produced. So again, I go back to stoichiometry. I know that 4 moles of water, if that gets produced, it's going to produce 2,220 kilojoules of energy. So again, it's a stoichiometric ratio again. So I write down what's given, 15 grams of water. For all these, converted to moles. We've been doing that for a long time. So I got the molar mass. Once I got the moles, well, 4 moles of water will produce 2,220 kilojoules. So if I do that, I'm going to end up with 480 kilojoules of energy. So again, it's just back to stoichiometry. I mentioned a big part of this class is stoichiometry. We write the stoichiometric ratios. 4 moles is equal to 2,220 kilojoules of energy.